All right, today we're talking about Chapter 1, Section 1, Linear and Rational Equations. All right. Alrighty, so starting here in the review chapter, excuse me, in the review chapter. Okay, so in your homework, you do have review sections. They're labeled R1, R2, so on and so forth. They're just a quick review of things that uh, you have definitely been taught. It's just a refresher. And in those review sections, we manipulated algebraic expressions. Right? An algebraic expression does not involve an equal sign. An equation indicates that two algebraic expressions are equal. Right? So for example, 2x plus 6 and 5x, they're just algebraic expressions. Okay? Think of equations as equal, 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 right? With an equal sign, right? So an equation is an equal sign. Expressions are just, well, there's math, right? Okay, so right here, by equating these two expressions with an equal sign, we obtain the equation 2x plus 6 is equal to 5x. The equation this equation is an example of a linear equation in one variable. Okay, so linear equation in one variable. Let's break this down real quick. Hopefully you have seen or heard, right? Linear. The root word there is line, right? So this is an equation that makes a line, right? Just a simple line. Okay, linear equation in one variable. That just makes all too much sense, doesn't it? Right? There's only one variable, right? We look here. There's the only variable here is x. It's there twice, yes, but there's only one variable. A linear equation in one variable involves any constant and variables that are raised to the first power. Examples of linear equations in one variable include the following, and all of these. Okay, so again, a linear equation is just basically that variable raised to the first power. Okay, obviously we'll talk about variables raised to higher orders of power, squared, cubed to the fourth, and so on and so forth. But for today, we're talking about linear equations. And then we get to the definition. A linear equation in one variable is an equation that can be written in the form ax plus b, where a and b are real numbers and a is not equal to 0. Okay, well, why can a not be equal to 0? Well, if a was equal to 0, that would just zero out, wouldn't it? It would just be 0 times x, which is 0. So we'd end up with simply just a b is equal to 0. So that's why we have to add the a is equal to 0 there. Let's get to a good actual problem instead of reading how to do one, right? Okay, so example 1. All right, so example 1, solve a linear equation with integer coefficients. Alrighty, so this is saying with integer coefficients. So an integer would be a whole number, right? And a coefficient is our number that is in front of the variable. Well, anyways, before we begin, what we're going to have to do is we're going to have to break down the walls here. We're going to have to get rid of these parentheses. Okay. In order to do that, what we're going to do is we're going to distribute. Okay. So first thing we're going to do is we're going to take this 5 and distribute it over that x and that negative 6. So we're going to end up with a 5x minus 30. And then we've got a minus 2x is equal to 3. Alrighty, and then over here what we're going to do is we're going to distribute a negative 1, right? Because that is technically a negative 1 there, right? So we're going to distribute the negative 1 there. So basically what we're going to do is just distribute a negative sign through the parentheses, and so we're going to have a negative x minus 1. Okay, and then we'll say so minus x minus 1. Okay, so we got rid of the parentheses, and now all we have to do is just combine the like terms. So I don't necessarily do things the way you might have done in high school. You know how you do this 2x plus 2x cancel plus 2x, right? Minus 5x cancel. I don't really do it like that, mainly because I feel like we are beyond that. So what we're going to do instead, we're just going to do some quick simple math, right? We'll combine like terms on either side and then just kind of do things in our head. All right, so on the left we have a 5x and we have a negative 2x, so that's going to be a positive 3x, right? And then minus 30, and then is equal to 3 minus x. Okay, well that's okay, but then we have a minus 1, so we're going to end up with a 2 minus x. Okay, now again, if you wanted to, you're more than welcome to do the whole, plus x thing. But I just feel like, again, give it a shot. Just try to do things quickly, and use some of your brain power there. All right, so we're going to add x to both sides. So we're going to end up with, you know what? I'll just go and do it for right now. All that talk, and here we are, huh? Okay, so we're going to end. Oh, well, that was an accident. Plus x. Okay, so we're going to have a 4x over here, and then what we're going to do is we're going to add 30, and then we're going to add 30 here. Okay, so we're going to end up with 32. Actually, that's a little small. 32. All right, so my final solution will be x is equal to 8, right? We have 32 divided by 4 is indeed 8. So my solution, x is equal to 8. Real quickly, actually, let's snip this, even though I didn't do it. Okay, so this reads, you should now check by substituting x equals 8 back into the original equation. Check your answer when finished. Now, if you're anything like me, which I'm pretty sure you are, you just kind of assume that you're either right or you're wrong and you move on, right? And I am that way. All right. Now, you're more than welcome to plug this 8 back into our original equation up here, onto the x's, and then you'll see that they do indeed work out. However, I don't do that. All right. Again, I'm either right or I'm wrong, or I move on. Okay. But there's a caveat there. I only do that for our linear equations. All right. Whenever we get into rational equations, then I definitely do check my solutions because it's very important. Okay. Because you end up with something called an extraneous solution, which we'll talk about when we get there. Okay. So. Example 2, solve a linear equation with integer coefficients. What's that? Okay, I guess we just have to do it twice, huh? Alrighty, so we're going to do this again. What we're going to do is we're going to go ahead and put the 6 out here, and we're going to distribute this negative 4. So we're going to have a minus 4x minus 16. Let's see. Real quickly also, my ones look like this, my sevens look like that. It's just a habit I got into because just to kind of distinguish a 1 from any sort of variable. Plus, I mean, I just think it looks better sometimes in equations, and you might get a little confused, but just remember my sevens had a little line through them. Okay. Now, sometimes I might get a little flamboyant and make my ones, make the flag a little bit long, and I'll try to correct that. But for the most part, my ones do have that little flag there, and sorry if that confuses you. Anyways, moving on. So on the right side, we have is equal to 8x. And then again, we're going to distribute. We're going to distribute a negative 2 through now. So we're going to have a minus 6x and then a minus 10. Okay. Alrighty. So same thing as the previous example. What I'm going to do is I'm going to combine the like terms on either side. So on the left side, we're going to have a 6 and a negative 16. So we're going to have a minus 4x, and then we're going to have a minus 10. Okay, because the positive 6 and the negative 16 gives me a negative 10. And on the right side, we're going to have, looks like we're going to have a 2x, because 8x minus 6x, and then a minus 10. Okay, all right, and then we're going to, well, I guess it doesn't really matter where I go here, does it? All right, so I'm going to go ahead and add 4x to both sides. So in order to, so I'm going to do this. I'm going to add 4x. All right, I don't do this all the time, but we'll do it for right now. So we're going to have 6x. And then we're going to also subtract or add 10 to both sides. So that's going to cancel that. We're going to add 10 over here. And then we've got 0 is equal to 6x. And then we divide both sides by by 6. And we've got x is equal to 0. Okay. And let's see. Okay, good. X is equal to 0. And the same thing. You can plug it back in if you're just trying to slide back into college algebra, then I would suggest it. But again, I don't do it for these types of problems because they are just linear. You're either right or you're wrong. But maybe we'll get into the extraneous on the next one. I don't remember. Okay. We definitely will. I just don't remember when. All right, here we go. So, I've got bad news for you. I've been doing math for a long, long time, and I still hate fractions. Okay, so chances are you probably hate fractions, and you're still going to hate them. But the thing is, they're really not that bad once you get past that first step. So let's go ahead and get past that first step. All right. So reading from the top, this reads: to solve a linear equation involving fractions, we want to first transform the equation into a linear equation involving integer coefficients. We do this by multiplying both sides of the equation by the least common denominator. Okay, so the least common denominator, what we're going to do is we're going to look at the denominators here. We have a 3, and we have a 2. Okay, now what is the smallest number that both 3 and 2 go into? Okay, well that would be 6, right? So what I'm going to do is first look at the chat. Oh, so yeah. So yeah, 6 is indeed the number that we're going to go into. Excuse me. So let's go ahead and rewrite the problem real fast. See if we can clear that. Alrighty. So here's what we could do. One of two things. Whenever we write, whenever we're trying to raise or multiply both sides by 6, okay? We could, if you want to, you could do this. Okay, and there's nothing wrong with that. That's perfectly fine. But I like efficiency, right? So I want to be quick and efficient. So instead of doing that thing where I multiply both sides by 6, what's wrong with just simply multiplying the entire problem by 6? Okay, so we can do that as well, and I am going to do that. Right. So what we're going to do is we're going to multiply by 6. So we're going to distribute through here. So 6 times a third. Well, that's going to be 2, and then it's going to be 1 minus x. And then we multiply this 6 through here. Okay, so this is what it's going to look like. Okay, I do know that multiplying a fraction, and let's actually put that over here. So we're going to be doing 6 times x plus 1 over 2. Okay, so that's essentially this step that we're doing right now. And I do know that multiplying into a fraction does, especially if you haven't done this in a while, is kind of confusing. So 6 times x plus 1 minus 2, and keep in mind it's also a negative, right? So probably wouldn't kill us to go ahead and put that there. A negative. Okay. Anyways, so what this essentially turns into is 6 and then x minus 1 all over 2, and of course it's a negative sign there. Okay, and that makes sense, and the reason why is let's go back, let's think about, you know, the good old days of just doing fractions like this. Okay, remember that what you do is you multiply that number by the numerator, right? Because this is essentially, this 3 in front is essentially 3 over 1, isn't it? And then it makes it a lot easier, or we recall now rather, that just looks like this, 9/4. Okay, so that's why we did this over here, and I'm gonna see if I can't try to keep that there for us to reference. Alrighty, so Anyways, oh yeah, and then after that, recall that we're going to reduce it, right? The 3 and the or 6 over 2 reduces into 3 over 1, which is just a 3. So we've got a minus 3 and then x minus 1. And then we multiply this 6 all the way about that. So we've got, I don't even know if that was English, negative 12. Okay. And then we get to the point where it's basically the exact same as the first two problems. Okay. So I don't think there's anything fancy with this one real quick. No, yeah, so 11/5 is our solution. So we will solve this one exactly like would the first two problems. I'm just in a hurry to get to extraneous solutions, and I wasn't sure. Although if I would have just looked at my denominators, I would know that it does not have one. Man, we're still not going to get there. Okay, so let's just look at this. We're just going to snip this instead of looking at the stuff written above it. Okay, so similar to fractions, I hate fractions, you hate fractions, we all hate fractions. Something else we all hate is decimals, okay? Nobody likes decimals, but again, once you get past that first step, they're really not that bad. Okay, well, what is this first step? Alrighty, well, if we look at decimals, we'll start with 0.1. Actually, let's do this. Let's do 1, 2, 3, 4, 5, 6. We'll go to 6, okay? So that's a 0.1, 2, 3, 4, 5, 6. All right, we know that this first one is called the tenth place, the tenth, right? This is the hundredth, this is the thousandth, this is the 10,000th, this is the 100,000th, I guess that would be the millionth, okay? So the way we fix up this problem with decimals is what our end goal is to make it look something easier to solve. Alrighty. So what we're going to do is we're going to look at all the decimals. We have a 10th place, we have a 100th place, and we have a 100th place. Okay. So what we're going to say, or we're going to ask ourselves is, okay, so which of those is the smallest, right? And obviously it would be 100th place, right? Because it goes tenths and then hundredths. So the 100th place is the smallest. So therefore what I'm going to do is I'm going to multiply this entire problem by 100. Okay, so what that does is it clears up all these decimals to get them into nice, solid, round, whole integers. Okay, so we're going to multiply the entire problem by 100, and let's go ahead and just no, let's write it out. Okay, so what we're going to do is we're going to multiply this entire problem by 100. So we're going to do this, and we're going to put a 100 out here. Okay, alrighty, and then we just distribute. Okay, so we're going to distribute this 100 through to this first term. Okay, and I guess let's see here. I want to go back to the previous problem real fast. When I distributed the 6, it looked like I just distributed onto the 1/3, and I actually kind of did, right? But the reason why is because this is the entire first term, okay? And multiplying it by that 1/3 doesn't really change anything, okay? Because what I'm doing essentially is I'm saying 6 times 1/3 times 1 minus x. Okay, that's what distributing the 6 basically does, is I'm just multiplying it by the first term. And so it doesn't really matter which one I multiply it by, but obviously in the end, 6 times 1/3 is always going to be 2. Okay, so it did look like it was just kind of like the 1/3, but it was the entire first term. So hopefully, if that was a question you were thinking of, that answers it. Okay, so I said all that to say this. What I'm going to do is I'm going to distribute here through to this first term, but realistically the one I'm going to be looking at is just that 0.1, right? Because it's 100 times 0.1 times y minus 2. All right. So anyways, I tend to have, to over-explain things sometimes, and that might be one of those cases. So anyways, we have a 10, then we have a y minus 2, and then plus 3 times a y minus 4, and then a 2 times a 10. Okay, and then same as the last problem, we have now reduced this down to problems like examples 1 and 2. Alrighty, so our rational equation, so all of this is going to get snipped here. Kind of important. Question, can you explain how you got the 10? Yes. First, let me see if I can snip all this first, because I got the snip tool out, and it goes kind of crazy if I don't use it. New page. Okay. How I got the 10. We talking about the first 10? That has to be the first 10, right? Okay, so how did I get the first 10? Alrighty, so what we're doing here is, again, we're doing 100, essentially 100 times 0.1 times y minus 2. Okay. Am I moving at a certain distance? I mean, yeah, kind of, but I mean, what is 100 times 0.1 or a tenth? What's a tenth of 100? Well, that would be 10. Does that make sense? Okay, good. And I mean, but oh no. Yeah, of course you can. Um, yes, the answer is supposed to be 4, I believe. But yeah, there's definitely a way to, yeah, our answer is 4. You can see right here. It's 4. Losing track of everything here. Is there a way we can visualize moving the decimal instead, or should we rely on 0.1 times 100? Okay, so here's the thing about that. Yes, you can visualize that, okay? And there's nothing wrong with it, and you might have been told a quick way to do it in the past, something like, okay, so it's 100 times 0.1, then you take this and you move the decimal over 1 point, okay? And then you get to 10. Same can be said for the others. 100 times 0.03. Well, actually, give me a second. Trying to. Oh, that's what it was. Moving the decimal over 2 gives me 1, 2. Heck, I don't remember actually. I honestly don't remember that rule. I'm sorry. I just at this point in my career, it's kind of like doing long division, right? I mean, if you're asked to do long division now, you'd probably forget about it, but a third grader could teach you how to do it. I don't know. At this point, I just kind of know that a tenth of 100 is 10, or if you wanted to, you could always just slap it into a calculator. I'm gonna have to refresh on the moving the decimal places over and stuff. I do feel like that would be a lot easier, but again, multiplying things. Oh, here it is. For these problems, you're either going to be multiplying by 10 or 100 and maybe 1,000. I don't know. But you're multiplying it in terms of tens, right? So it isn't abundantly difficult because the main point we're trying to do is we're trying to get this 0.03 and the 0.02. We're trying to get them out of the decimal places. Okay, that's why we chose 100. So we'd say 100 times 0.03, well that's just 3, and 100 times 0.02, well that's just 2. Okay, and then of course the 100 times 0.1, depending on whatever this is, if this was a 3, well 30% of 100 would be 3. I'm sorry, 30. Um, so doing the quick mental math on these shouldn't be abundantly difficult because you're doing it in terms of tens or 100s. Hopefully that answered your question. Yeah, well, That's the thing is it's going to be 100. It's going to be 10 or it's going to be 100. And to be completely honest with you, if it was any other number, I would just use a calculator, and I will. Like if somebody was to ask me, what's 137 times, 0.03, I'd be like, I'll just use a calculator instead. So yeah, it is going to be in tens or 100s. All right, good. All right, so all right, I already copied this, so let's go to that. All right, so a rational equation. All right, start from the top, and I'm going to click this and get rid of it. All right, recall that a rational number is the quotient of two integers. Okay, so a rational number is being a quotient of two numbers, so that would just be a ratio. Again, we're looking at the root word. You've probably seen or heard that before, ratio or fraction, correct? A rational expression is the quotient of two polynomials such that the degree of the polynomial in the denominator is greater than or equal to 1. Okay, so that's pretty important. Let's see. Such that the degree of the polynomial in the denominator is greater than or equal to 1. Okay. A rational equation is an equation that contains one or more rational expression. The precise definition of a rational equation is given below. Right? So a rational equation is an equation consisting of one or more rational expressions with any other expressions of the equation being polynomials. Okay, so this definition isn't quite as rigorous as I would like, which is why I'm going to underline what I underlined. Okay, so we see our examples there, examples of rational equations, including the following. All right, so what we're going to do is we're going to look at, okay, so do we have a polynomial in our numerator? And do we have polynomial in our denominator? So let's read it again. Rational equation is an equation consisting of one or more rational expressions. Okay, so again, a ratio, a fraction, with any other expression of the equation being a polynomial. So we're basically looking at some sort of polynomial over a polynomial. Okay, and of course, our three examples here, we have this polynomial over this polynomial. Good, that's pretty easy. We have us a polynomial here and polynomial there in the denominator. That's good. And of course, we have polynomials here in our denominator. Okay, so these are indeed obviously rational equations. Well, example 5 reads, determine which of the following equations are rational equations. Okay, well, I can tell you right now that A and C are rational equations because we have our polynomials in our denominator. Okay, now let's look at the top of where I underlined it. It says a rational expression is the quotient of two polynomials, okay, such that the degree of the polynomial in the denominator is greater than or equal to 1. Okay, so if we were to look at A and C, we do indeed see that we have polynomials in the numerator and the denominator, and we also see that the degree, all right, of the polynomials in the denominators are, well, they're actually just 1, right? This is essentially x minus 5 raised to the first power, right? This is essentially x plus 2 raised to the first power. And then same thing, well, that would be a second degree polynomial. But, we can see that they are indeed a polynomial that raised to the first power. Well, obviously, I didn't say b was a polynomial because it is not. And here's why. If we looked at b, okay, you would say, well, we have a second degree polynomial there, right? And then, it's technically over 1, right? Yeah, so it's technically a fraction, so therefore it's technically a ratio, therefore it's technically a rational expression, right? Well, that's where the underlining part above comes into play. It reads, such that the degree of the polynomial, again up here, the degree of the polynomial in the denominator is greater than or equal to 1. Okay, so if 1 was in this denominator, okay, which it is, right, because again, it's technically a 1, well, what is the degree of this 1? Well, it is raised to the 0th power, okay? And anything raised to the 0th power is 1, all right? Well, it doesn't satisfy the has to be greater than or equal to 1, right? Because, well, it's 0. The degree of the denominator is 0, right? So that's why B is not a rational equation. Okay, now real quick, let's see here. We'll not cover that up. All right, you can think of your own shortcuts here instead of thinking the long way there. Basically, if you just have a polynomial by itself, it's not going to be a rational equation. Okay, So that's that. Excuse me. All right, so now we're going to get to the solving of rational equations. Real quick, let me check this out. Nice. Okay, so this is where we need to check our solutions. Okay, we're finally where I was expecting us to be a long time ago. But that's okay. We learned a lot of stuff in between. So starting from the top, a rational equation always contains at least one expression that involves a numerator and a non-constant denominator. The process of solving a rational equation is very similar to the process of solving linear equations containing fractions. That is, we first determine the least common denominator. Makes sense, right? Back here in our we had fractions. Well, how do we clear the fractions? We multiplied the entire problem by the least common denominator, and that's how we cleared the fractions. Well, that's what we're gonna have to do here. We're gonna have to multiply by the least common denominator. Okay, right here. We have to be extra cautious when solving rational equations because we have to be aware of the restricted values. Okay, well, let's just for the sake of fun, ignore that last sentence. Okay, so here's what we're gonna do. We're gonna rewrite this problem. And I hope I have enough room. Okay, so I need to multiply this entire problem by the least common denominator. Lucky for us, our work's cut out for us. It's really easy. The least common denominator is x plus 2. Okay, well, if we distribute the x plus 2 through here, let's make it blue like we did last time. If we distribute the x plus 3 through here, well, the x plus 2's are going to cancel out, right? So we're going to have simply a 2 minus x, and then we distribute the x plus through again, and so this is going to turn into, now pay attention here, I'm multiplying x plus 2 times 3. Okay, so I'm going to take that sign that's in front, all right, the sign right here is a plus sign, okay, and then it's just going to simply turn into 3 times x plus 2. Okay, now if you wanted to, and I don't suggest this actually, you're going to be tempted to do this, but don't do this. You're going to want to do something in your head, and you're going to want to go ahead and say 3x plus 6. Okay, now for this problem, it probably won't make a difference, but for later problems later on in the semester, it'll just make it easier if you don't go ahead and do that, because we might end up canceling the x plus 2 out somewhere. All right, and you're going to be completely lost if you go ahead and try to do that math in your head, which is kind of counterintuitive, because you're like, oh, we're trying to figure out the problem here. Well, I'm telling you now, don't do that. Anyways, and then lastly, we're going to distribute the x plus through to the last one. All right, and again, the denominators cancel, so we're just going to end up with a 4. Okay. Alrighty, so at this point we've got a normal equation, and normally I'd be like, well, it's just like the previous problems, but obviously I know that there's a trick to this one, okay? So we're going to actually finish this particular problem. So let's go ahead and do the arithmetic here. We're going to have a 2 minus x, and it's going to be a plus 3x plus 6, and again, I said probably won't make a difference for this particular problem, but later on in the semester it will. Alrighty, so let's move this up here. Okay, so we're going to have, we're going to combine the like terms. So on the left side, we have a negative x and a 3x. So we're going to have a 2x, and then we've got 8, and then we're going to subtract 8 from both sides. So we're going to end up with a negative 4. Okay, and again, that's just some mental math there. All right, so we've got 2x is equal to negative 4. So we're going to end up with x is equal to negative 2. Okay, now, this is where just assuming you're correct will get you in trouble big time, okay? Because we're going to have something called extraneous values, right? So anyways, before I continue on there, let's look at this. If I were to just say this is the solution and I move on, I would be 100% wrong. Here's why. If I plugged this negative 2 in to either of these denominators, let's actually do a little better, to either of these two denominators, okay? Well, what is negative 2 plus 2? That's 0. All right, and you can't divide by 0, right? I mean, when you're 80 years old, the one thing you're going to remember, well, hope maybe two things, the Pythagorean theorem, and you can't divide by 0. Okay, so we know we cannot divide by 0, so therefore this is not a solution. But we did everything right, right? I mean, all this stuff down here, everything we drew, everything we wrote is correct, but you're telling me it's wrong, and that is true, okay? And this is what an extraneous solution is. An extraneous solution um, might just be my favorite thing in mathematics because, just like life, you could do everything right and still be wrong. All right, there's you some philosophy for today. So this is incorrect because it is an extraneous solution. Let's go ahead. Let's see if I can. Is that worth a solution? Yeah, we'll go and snip that in there. Okay, big time here. So this is something that you definitely want to make a note of. Okay, so an extraneous solution, just reading from the definition, is a solution to an equation obtained through algebraic manipulation that is not a solution to the original equation. Again, you did everything right. You were just wrong. It happens. Life lessons. All right, so solving rational equations. I'm going to snip this, but I'm not going to follow it rigorously because I feel like sometimes what you'll do as a student is you will, maybe I should erase that, huh? Is you will fill up your brain with so much stuff that you just kind of run out of room, okay? But I'm going to keep this here, but again, I'm not going to follow it rigorously because I will speak through all this and I will essentially hit steps 1 through 5, but I won't follow them rigorously. Okay, so example 7. Oh, this looks ridiculous. Okay, that's great. Look at all that mess down there. Alrighty, so example 7. Solve a rational equation. Alright, so the first thing that I'm going to want to do here is I'm going to want to factor. So was that the first one there? Yeah, factor. Good, see? Alright, so the first thing you want to do is factor. Now here's the thing. Actually, let's do this. This step is step 1 for the rest of your life. I promise you, okay? You need to factor. All that stuff that you learned in Algebra Essentials or Intro to College Algebra, depending on where you learned from first. All that stuff that you learned, you have got to remember. You've got to relearn, or you're going to fall behind. Okay, so factoring is the first thing that we need to do. So let's go ahead and factor. So this first term doesn't need to be factored. That's pretty nice. The second term doesn't need to be factored. That's also pretty nice. The third term does need to be factored though, okay? So we're looking right here at this denominator. It does need to be factored, all right? And if you forgot how to factor, look at the review sections. Remember ASAP. You will not get beyond chapter 1 if you do not know how to factor. Anyways, so what does this factor into? Okay, well, I can tell you right now just because, well, I mean, obviously, I've done this for a long time, but it's going to factor into these two. The reason why is because, well, that's how a textbook is made, all right? But in case you didn't know that, let's go ahead and write it out real fast. X squared minus x. Actually, let's put that down here. Minus 20. Okay. So in order to factor this, you have to say to yourself, you have to ask yourself, okay, so we have negative 20 over here. So what are the factors of negative 20? That will give me a negative 1, right? That's an implied negative 1 right there, right? Well, my factors of 20, my only factors of 20 are, as a matter of fact, 5 and 4, right? 3, 4, 5, 6, yeah, 5 and 4 are my only factors of 20. And then when you add or subtract them together, what will give you a negative 1? Well, that's pretty easy. It's going to be an x minus 5 and an x plus 4, which, like I said, are these two problems, or these two denominators. Okay, look for that. Look for that in the text, but obviously, also know how to do it. So anyways, x minus 5 plus 4. Okay, so real quick, I kind of do want to expand on how how I knew that right off the bat, obviously because I've taught this before, but yes, mainly because if these were, if this was a 9, if this was a 6, okay, the least common denominator would be 4 terms. It'd be this, 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 and this. And nobody's got time for that, at least not right now. Okay, so that's another reason why it's just going to be an x minus 5 and x plus 4. Okay, so again, we're going to be multiplying by my least common denominator. All right, my least common denominator, as I just said, was x minus 5, x plus 4. Okay, so previously, I did have this out front, and we kind of distributed this way, right? Well, it doesn't really make a difference. I mean, 3 times 4 is 12, 4 times 3 is 12. So we're gonna be distributing kind of backwards. Okay, so we're gonna say, this times this. Okay, well, what is x minus 5 times x minus 4 times 2 over x plus 4? Well, it does seem a little tricky, and let's actually go ahead and write that out real fast. All right, so let's write it out in the same orientation that you see it. All right, and it's going to be that. It's going to be multiplied by x minus 5, x plus 4. Okay, so that's essentially what the distribution process looks like right now. Okay, well, if you recall, you can just simply kind of I miswrote that. That's why. Boom. Okay, you can just simply cancel that, right? And so what you're left with is simply 2 times x minus 5. Okay, 2 times x minus 5. So that's what we're going to do with all of these, right? This x minus 5 is going to cancel with this x minus 5, and then both of these are going to cancel with both of these. And of course, I'm going to take John Madden off the screen here and continue on. Okay, here we go. All right, so we said the x plus 4s are canceled, so we end up with a 2, and then x minus 5. And then it's going to be plus, and then x minus 5's cancel, so we're going to have a 1 times x plus 4. So we can just simply say x plus 4, right? I mean, 1 times anything is that anything, right? And then I said on this one, well, the entire denominators cancel with one another, so this is just going to equal to 5, right? All right, so now at this point, what we're going to do is we're going to distribute our 2 through, so we're going to have 2x minus 10, and then we can just go ahead and drop that parentheses, so we're going to have plus x plus 4 is equal to 5. Let's see here. It's equal to 5. I think I have room. Okay, and then what we're going to do from here is we're going to combine like terms, so we're going to have a 3x on the left. Okay, and then we're going to combine, again, just quick mental math. We have a negative 10 and a positive 4. That gives me a negative 6. And so in order to get that negative 6 to the other side, I need to add 6. So adding 6 to 5 gives me 11. So we're going to have a 3x is equal to 11. And therefore, we've got x is equal to 11 third. Okay, so that wasn't nearly as bad as I thought it was. All right, but again, how do I know this does not contain an extraneous solution? Okay, so the reason why I know this is not an extraneous solution is because looking back at my original problem, and again, this is the original problem as well, right? I'm going to look at the denominator, okay, and I'm going to look at the variables in the denominator. Okay, so as long as I do not have a 4 right here, I'm sorry, a negative 4 here, or a 5 here, or a 5 here, or a negative 4 here, I will not have a 0 in the denominator. Okay, so basically what I'm saying here is, and let's put this up here. Let's put it up here. Okay, I'm gonna put RV for restricted value. Okay, restricted value. I cannot have a negative 4 or a positive 5. Okay, so I cannot have a negative 4 or positive 5 in my solution, and if I do, then I'll have an extraneous solution. Okay, well, obviously in our solution we have an 11 thirds, and therefore it is not negative 4 or negative 5. Okay, now real quick, let's go back to an earlier problem. Okay, an earlier problem where we did actually have a fraction, but there was no chance of an extraneous solution, and that would be example 3. Okay, so it's not always fractions. It has to be fractions, okay, or I'm sorry, rational polynomials, um, where you have a variable in the denominator. Looking here is a 3 and this is a 2. There is no variable in the denominator. Okay, so you don't have to mess with those if you don't have a variable in the denominator. Looking at uh, this particular problem, we do indeed have a variable denominator. We have an x, and it's we're adding 2 to it. Same thing over here, and then that's how we got the extraneous solution, right? We got the solution x equals -2, and that happens to be the only number that I cannot use. So that was an extraneous solution. Um, Same thing. Well, this is the problem, right? What we're looking at is to see if we have a variable in the denominator. If we have a variable in the denominator, then we will have restricted values. Okay, so hopefully that helps. I don't know. I feel like I again talk a lot sometimes. It's been a while, guys. I was on Christmas break. All right, so that's example 7, and x equals 11/3, just like we said. And example 8, and I believe this is the last one. So yeah, we are way ahead of schedule. Okay, so excuse me. Let's go ahead and begin this. So I said the first thing we're gonna do is we're gonna factor. Okay, so let's go ahead and factor. So we're gonna again, we no. This is gonna factor into x minus 1, x plus 2, right? Because again, if it didn't, then we're gonna have that absolute absurd least common denominator. We'll be multiplying by 4 terms. Now watch me be wrong there. Okay, so we got x squared plus x, excuse me, minus 2. Okay, if we factor that, all right, so what are my factors of -2 that give me a +1? Okay, well, actually it does. So it's x plus 2 and x minus 1. So yeah, everything works out nice and neat. Excuse me. So let's go ahead and rewrite this now. So we have a 12 over, and then we factor that denominator. We factored it into x plus 2, x minus 1, minus x plus 3. When I write small on this tablet, my flags don't really come out too great. That's why this 1 doesn't look right. But also I just don't like the way those ones look. So let's try and make a little flag on it. There we go. Okay. Anyways, moving on. Plus 2. There we go. Alrighty. So we did all that. Now we need to multiply by the least common denominator again, and the least common denominator would just simply be x plus 2, x minus 1. Right. So let's begin the distribution process. So we distribute here. So we end up with simply a 12, right? Because the denominator just completely cancels out with what I'm distributing by. Then we've got minus, and the x minus 1's cancel, so we're going to have x plus 3 times x plus 2. So this is going to be a doozy of a problem. And then over here we have a 1 minus x times x minus 1 because x plus 2's cancel. Okay. Excuse me. So this 12, that's the easy one, right? And then we got minus, and then at this point, again, once you go over your, if you haven't already, when you look at your review sections, you will recall the FOIL method, or it's just simply distributing polynomials. Okay, it's just FOILs are specifically two binomials. Binomial meaning two polynomials, right? Two that whatever. But anyways, so this turns into, and let's go ahead and put this in a bracket here. We've got x squared plus 2x plus 3x plus 6. Okay, and I'll give you a little jump start in case you did forget. Remember, you do the first two, and that's where we got x squared. And then we do x times 2, and that's where we got 2x. We do 3 times x, that's where we got 3x. And then we did 3 times 2, which where we got 6. Okay, so everything is accounted for. Everybody has paired off at some point or the other. Okay, so that's what we need to do there. Also, notice how I put these in a bracket there. I mean, bracket, parentheses, doesn't matter. You need to do it though. Okay, let's say for instance I didn't do that. Okay, let's say that I didn't put that bracket there. All right. Well, that subtraction sign would just be subtracting the x squared, wouldn't it? Okay. But looking at the problem up here, it's actually subtracting this entire term here. Okay, so that's where a lot of people get into trouble with your negative signs. So try to make sure that you're taking each step logically, and that you're not in a hurry. Okay, because that'll definitely get at least like 80% of you. Maybe you know what? Maybe 70%. At least the first time. Okay, but anyways, let's do it. Let's move on to the second one. Okay, so we got 1 times x. We've got x, and then we've got a 1 times a negative 1, so that's gonna be a negative 1. And then a negative x times x, that's a negative x squared. And then negative x times a negative 1 gives me a positive x. Okay, and kind of want to, I wonder, I'm gonna see if I can go one more down before I snip. All right, so I've got 12 minus x. We're going to distribute that negative sign now. So we've got negative x squared minus 2x minus 3x minus 6. Okay, which would be radically different than if we didn't put the bracket there, right? The negative x squared, that would be right for both, right? But obviously, since we had to distribute the negative sign through, we have a negative 2x, negative 3x, and a negative 6. So again, it's very important to take your time with this. Excuse me. And that's equal to, let's go and put this in descending order. So we're going to have a negative x squared. Excuse me. The two x's combined, so we've got a plus 2x, and then minus 1. And then let's see if we can snip here. To the new page. Okay, good. It didn't take that along with it. Okay. So we're still chugging along here. We've got somebody said something. Why is the x squared and minus? Because if we are doing the FOIL form again, and I'll go ahead and just take the steps as well. Okay, so we did 1 times x gives me a positive x. We did a 1 times a negative 1. 1 times a negative 1 is a negative 1. A negative x times x is a negative x squared. And then a negative x times a negative 1 is a positive x. Okay, that help out? Did that help you out, rather? Okay, good. Anyways, continuing on, let's go ahead and combine like terms here. So we're going to have a we're going to combine on the left side. Let's go ahead and combine like terms and put it in descending order. So we're going to have a negative x squared. The x's here, we have a negative 5x, and then 12 minus 6, we have a plus 6. And on the right side, well, the right side's already nice and combined in descending order. Okay. Alrighty. So anyways, now we're going to put things off to one side. Okay. So looking right away, we have the negative x squareds. Well, I mean, if I add x squared to both sides, right, they end up canceling, right? And so what we're going to do now is we're going to go ahead and we're going to add. I like to have my variables, or I'm sorry, the coefficient on my variables be positive. You don't have to, but I like to. So what I'm going to do is I'm going to go ahead and add 5x over here, add 5x over here. So we have a 7x. And then we're going to add 1 to both sides. So we're going to add 1 over here. Oh, my arm touched it. Add 1 over here. And so we end up with, oh, they don't cancel. Now we have a 7, and that's equal to 7x. Therefore, we have x is equal to 1. Okay, so let's go back. And I'll be honest with you, I probably should do restricted values first, but it really doesn't matter, I guess, if I do it first or last, as long as you do it, okay? So we're going to ask ourselves, okay, so did my problem have a variable in the denominator? Yes, it did. Okay, we have the x in the denominator. If you just have one, then you need a full stop and think about your restricted values. So what are my restricted values? And again, probably could have done this first. But anyways, my restricted values, it looks like it is a -2 and a +1. Okay? If I have a -2 or a +1 as a solution to this problem, it will not work. It will be extraneous. You will have done everything right, but you're wrong, right? Because again, if we put a -2 here, -2 plus 2 is 0. If you put a 1 here, 1 minus 1 is 0. So those are restricted values. So looking at my solution was x is equal to 1. Okay, well, x equal to 1 cannot be a solution, okay, because that is an extraneous solution. So therefore, this particular problem, it has no solution. Okay, all right, well, that concludes today's lecture.